Now let's look at manganese 2 ion. Manganese is 3D5,4S2. Now manganese 2 is formed when manganese atom loses what? 2 electrons. So this 2 will go, the 4s2 will go away, so we'll be left with 3D5. Then manganese 7 ion will be what? Formed when manganese atom loses 7 electrons, that is the 2 here and the 5 here. So we'll just be left with the 1s2, 2s2. We'll be left 1s2, my pen, 1s2, 2s2, 2p6, 3s2, 3p6. That is, you'll be left with the argon part. Now, what are the properties of transition elements? They are all metals with typical metallic properties such as high tensile strength and high melting point. They have variable valencies. They have variable what? Valencies. They have variable oxidation state. They have oxidation state that is more than 1. For example, copper can be +1, +2. You can have chromium as plus chromium 3, chromium 6, even chromium 2. Then for manganese, you can have +2, +3, +4, +5, +6, +7. So they have what? Variable oxidation states, with the exception of few of them like zinc, which is always 2, zinc 2, and scandium, that is always scandium 3. They are what? Their ions are colored. Copper 2 ion is blue, ion 2 is green, ion 3 is brown, manganese 7 is purple, chromium 6 is orange, chromium 3 is green. So their ions are usually what? Are usually colored, and they have the ability to form complex ions or complex compounds, and they are also what? Industrial catalysts of commercial importance, e.g. iron, copper, silver, gold, and maybe vanadium. Though vanadium is not one of the first 10, but it is also what? A transition metal. Now let's look at diagonal relationship in the periodic table. Now elements in group 1 normally should have the same or similar chemical properties, while elements in group 2 should have what? Similar chemical properties. But in the periodic table, there is what we call what? Diagonal relationship, and a diagonal relationship is said to exist between certain pairs of diagonally adjacent elements in the second and third periods of the periodic table. This pair, e.g. lithium and magnesium, beryllium and aluminium, boron and silicon, exhibit similar properties, though they are not in the same group. Lithium is in group 1, magnesium is in group 2, beryllium is in group 3, beryllium is in group 2, aluminium is in group 3, boron is in group 3, silicon is in group 4. So they are not supposed to show what? Similar properties, but these elements show what? Similar properties. So this is what we have here. We have lithium and magnesium, beryllium and aluminium, boron and what? And silicon. So we'll take what? In our next class, we are going to look at diagonal relationship in details. We are going to look at the properties of lithium and magnesium, the properties that they have in common, the properties that aluminium and what? Beryllium have in common. So we are going to look at our diagonal relationship in details. So let's take some practice questions. The alkali metals exhibit similar chemical properties because the alkali metals what are the alkali metals? They are group 1 what metals. Now they exhibit similar chemical properties because A, they occur in the combined states, they have the same number of valence electrons, they form crystalline salt, their salts are soluble in water, they are highly reactive. The alkali metals exhibit similar chemical properties because they have the same number of what? Valence electrons. So this is the right answer. An electron can be added to a halogen atom to form a halide ion with 8 valence electrons, because halogens all have what? 7 valence electrons. So if you're adding one more electron to give you what? 8 valence electrons. E.g., you have fluorine, which is 2, 7. You have chlorine, which is 2, 8, 7. So if you're adding one more to the what? Valence electrons to give you what? 8 valence electrons. So we've come to the end of this class. Thank you.